I'm Eszter Lakatos and I work as an assistant professor here at the mathematical department. I've been here for a year now. I just started a year ago in April. And before that, I was in London. I was doing a PhD in systems biology and then changed to do a postdoc in cancer biology. When I was applying for university, I very seriously considered just becoming a pure biologist because biology really interests me as well. I always went for the thing which looked the most interesting, and it turned out to be academia. I went to university with the thought that I wasn't looking for something that I will be this employable or that employable. I just wanted to keep on learning. And so then I did a PhD, and then I kind of found myself just on this path where the most interesting option turned out always to be the academic one. So I work in, I guess you could specify it as computational biology, so this applying informatics and mathematics to biology. And in particular, I'm working in cancer research. So I want to understand how do cancers develop and how they respond to the treatment. We have these big data sets where we can sequence the DNA of cancers and the DNA of healthy people, and then we can compare what is different between the cancer and the healthy cells. And then we need to use a lot of clever methods to really find what is truly different and what really matters there. So I'm working on finding out what matters and how these things change over time and how the cancer became the cancer it is now, so that then we can tell how it is going to go on in the future. I'm motivated about eventually finding better cures for diseases and really increasing our understanding of how diseases happen and what we can do about it. This is the final goal we are working towards with, and where I really find that motivation is whenever I get to work together with biologists or clinicians and have conversations and hear all these unsolved questions which they are facing day to day, and then occasionally finding ones where I go like, I think we could solve that for you if you just give me this and I can do that. So those are the moments where I feel very much like this is what I want to do. The whole big area, which I guess would classify as cancer genomics, is where I'm working, is extremely active. There is so much great work happening there. I'm part of this smaller community of mathematical oncology, so people who are using mathematics for understanding cancer. So a lot of the people there are coming from similar backgrounds as I am, mathematics or physics, but there's also a lot of biologists and clinicians. It's just a very welcoming community with a lot of good conversations. I just generally like to emphasize, and I probably haven't done it enough yet, is what a mathematician can do for a biologist. What I like to think I'm doing is that I could be maybe people who should be coming and talking to a mathematician, because maybe the mathematicians already solved that problem a long time ago, just called it something different. So in general, there should be more conversation between scientific fields. Very often we are talking about the same problem, we just call it very differently. I'm generally very passionate about people to know mathematics, and that this whole idea of that people are not good at mathematics, I think it's stupid and it's not true, and I think everyone can be good at mathematics, and I'd really like to see a world eventually where there is not this feeling that you just need to prove yourself a little bit more just because you happen to be a different gender or a different skin color than the others. Like, I'm from a father teaching mathematics who wanted me to do mathematics and engaged me all the time, but I think there are many people who are being kind of told that they are not good at it, or that they should be going for something more feminine. So I would like those people to also come and reach university level and do mathematics if they want to, and find the joy in it.